I think we did it. Hey, what's up, everybody? Welcome back to another 3D Hangouts. My name is Noah Ruiz. I'm a designer here at Adafruit, and joining me every week is CircuitPython Pedro.
What's going on, everybody? I'm Pedro Ruiz, Creative Tech here at Adafruit, and every week we come to share 3D printing projects featuring electronics from Adafruit.
That's right. This is a show we combine 3D printing, DIY electronics, smash them together to make inspirational projects. Yeah, so let's start off with the show. Thank you guys so much for joining us. We are live streaming on all the channels and networks. Let's start off the show with this week's coupon code. It is Shake It Off. So if you want to order anything in the shop, please use Shake It Off as the coupon code and gives you 10% off your order. Speaking of cool, sweet deals, we still have a lot of freebies going on. So if you go to adafruit.com/free, you can see all the different tiers and offerings that we have. Circuit Playground Express is back, so we are giving those out for orders that are, I believe, $189 or more, but double check the website to get all the details on that. We also have same-day delivery in New York City, so if you're in New York and you need some electronics like right away, you can use the same-day delivery option. CircuitPython meetings happen every Monday at 2 p.m. Eastern Time. It gets published on the YouTube channel, and it's recorded live on the Discord server, so adafruit.gg/adafruit is the invite link for joining the Discord chat room, which will be hanging out there for the rest of the day. The AdafruitDaily.com is newsletters. If you want to get a daily kind of newsletter of news and things in the community, you can go to AdafruitDaily.com and subscribe to the available categories that are there. Newsletters. We have a product focus one. This one happens once a week. Adafruit.com/newsletter for that one. Hanging out in the Discord chat room, we are there. I just put a little GIF there of this week's project, which looks pretty funny. This week's project is a Crickit-powered Lab Shaker. Lab Shakers are those equipments meant for like mixing chemicals and other things like that. So we put one together to help agitate our parts that use PVA support material. This was sort of an idea that Lamar had. Is like, hey, I see these DIY lab shakers. Would it make sense to use this for your guys' 3D printing? We're like, you know what? For dissolving PVA, that might actually be useful. So we put one together using the Adafruit Crickit Circuit Playground Express. We've been working on it for a little bit, and this is what we put together. So we have a guide that launched earlier last night. So this is the full assembly, programming, all the stuff that goes into the project. So it's all nicely documented here. So the homepage kind of covers all the parts that are used in the project. Again, it's just a Adafruit Crickit. You got the Circuit Playground Express and a DC motor. There are some other things that you need to power it. We're using one of the wall adapters, the power supply. It's a 5-volt 2-amp power supply. Nice and handy to have, as it's going to be running for at least over an hour, so you don't want to use a battery. Definitely want to have it plugged into the wall. We also have some other things like the potentiometer. This lets you control the motor speed. It also has a built-in on-off switch, so you can turn it on and off by cranking it up or turning it down. That's nice. This panel-mounted USB cable breaks out the USB cable. Since the Crickit is inside the case, we want to be able to access the programming, so we use this panel mount USB cable to panel mount it out. There are some hardware that you're going to need to put this together if you do so. There are some ball bearings, and some machine screws, some hex nuts. They're all listed here in this nice little parts list, so you can get those. There are also some little add-on, little accessories like the machine knob that's made out of aluminum. I actually got that from SparkFun. We carry some knobs, but I really like the one that SparkFun has, so I linked to that one. Tools. Got a nice assortment of tools that I linked here that help make the project really easy to build. So I got my screw taps, third helping hands, and soldering irons, all that sort of stuff are all there. Also, the PVA filament, in case people are wondering what PVA do we actually use. This is actually from Ultimaker's PVA. How's my sound? Is it okay? Mm-hmm. All right, cool. So that's the introduction. Why would you need this thing? Again, it's for agitating PVA parts. Maybe you want to, maybe you're printing resin parts and you need to cure them in alcohol. Maybe, that's actually the only example I have. I don't have any other examples. Why would you need to shake something ferociously?
For lab work.
Yeah, that's lab work. I'm talking like specifically post-processing. What else?
Oh, you could have like screws in there
to
do the copper or the brass.
Well, you could get a tumbler. The tumbler is better for that.
You could visualize it
like
there.
A tumbler.
Yeah.
Mm-hmm. Anyway, if anybody has any cool ideas and use cases for it, let me know. This is all we could come up with. All right, so let's talk about the circuit diagram. Since we looked at all the parts and sort of the gist of the project, let's go into the circuit diagram.
Yes, mixing drinks, making hot cocoa.
Oh, I
cleaning jewelry. There you go.
There you go. You can make some
cheaper
hot cocoa.
option than one of those. What are they called?
The stirrers, the magnetic stirrers.
No, the jewelry cleaners.
Oh, okay. The ultrasonic.
Yeah.
Yeah, we'll talk more about that. So for the circuit diagram, there's only, what is it, 3-4 components that are actually wired. What's really cool about the Crickit is that it has screw lock terminals, so everything just kind of plugs into it, and you just kind of tighten it with the little screw, so that's nice. The potentiometer uses the signal I/O header block, so it's like a female header block, and you just kind of plug in jumper wires into it. The only thing that needed some real wiring and some real soldering was the DC power jack and the DC plug. So those things, because we're using an on and off switch, we actually had to wire the on and off switch from the potentiometer in line with the voltage wire of the DC barrel jack and the DC plug. So all that's listed here, all the wire connections are broken out, written out here in nice text format. And you get a nice little image here. If anybody's wondering, we use Fritzing. It's a free open source software, and we have a library for Fritzing parts. So if you want to put together a circuit diagram, you can do so. I need to put a link to the parts. If you just search for Adafruit Fritzing parts, you will find it. So that's the circuit diagram. On to the 3D printing. So the 3D printed parts, they're up on GitHub and Thingiverse and all the other sites. There are quite a few bit of parts, so I broke them out in descriptions and titles. They're all titled and the descriptive, so you know what goes where. The next part is the CAD assembly itself. I put together a little CAD animation that explodes all the parts and kind of gives you a visual reference to see how all the screws fit together and how all the parts are pretty tight in there. It was really important to kind of model all the parts into this project because you really need to see all the parts if they fit, if there's any intersections and stuff. So I definitely recommend doing that if you have the time to do so. It's a little bit more time consuming, but it's definitely worth it to kind of see this and catch mistakes before you're printing out a whole bunch of iterations. Another thing I did here that's kind of different is I actually wrote out the dimensions and the build volume. So if people are wondering, well, will this fit on my printer? You don't have to download STL and take a look at it. I have it written here. So the box and all the parts should fit on a 120 cubed printer, maybe even a little bit less. The tray is 118. The numbers are there. The container we're using for this project is an 8-ounce container. That's just what I had on hand, but you can create or design or remix a new container holder, as the tray is just meant to kind of support and catch any liquid that might spill over. So that's why the tray is a little bit bigger than the container holder. So all the design source files, they're up on GitHub. I have a link there. Also the step files and STLs, so you can remix it. I like sharing the Fusion 360 source file. Because it contains the timeline, the sketches, that stuff. You don't get any of that stuff with the STL or even the step file. And the animation too is all kind of packed in there, so it's a nice, nice project file. So one of the parts to make this project work is the motion links, and the motion links they have some overhang geometry. So what I did here was, instead of printing with regular PLA supports, I really wanted to give the breakaway material a shot. So breakaway material is this special kind of blend of, I want to say nylon, or maybe it's copolyester, but it's from Multimaker. They make it, and it's designed to specifically be printed as support material. So the thing with this is that it creates some really, really nice kind of surface finishes. So typically when you print with PLA support material, it tends to have kind of a rough and coarse surface. So with breakaway material, you get this really, really nice surface finish. So here's one of the motion links. This is dual extruded, right? So it's PLA, the black is PLA, and the white is the breakaway, again from Ultimaker. So this was printed on Ultimaker 3, and you use the same print core. So there's no special print core necessary for printing breakaway supports. The first time we actually showed this on the show was a couple weeks ago. We printed a Lego adapted light switch panel, and that had like a whole overhang geometry. So it's a really big part, right, with a bunch of overhang, and it came out amazing. Where the bottom looks better than the top, and that's just like crazy. So what Pedro's going to do is he's going to break it off. You could do it with your bare hands. You want to try to break this off with your bare hands?
Yeah, let's see.
So here's some, it just snapped right off. Now let me do some focusing so you can look right up at it. We're going to do a little bit of close up here. Right about there. You can get, that is the bottom part that's printed as an overhang. And it's just amazing quality detail you get out of this thing.
Looks like the top.
Yeah, it looks like the top. So you get really, really clean parts. In the supports, it's kind of, you know, it kind of just breaks away in chunks. For this one, though, you have to kind of get in there and dig in there, but as you break it out, you'll see that there's a support interface. With that support interface, that's basically like 100% of filling that in. Look at that, that is amazing. This is where the ball bearings actually are snap fitted into. So you kind of have to have really nice and clean geometry. And the only way I was able to get this was with breakaway supports. Now we could have used PVA supports, but PVA is more for intricate designs that you actually cannot get to the supports. With this one, it's an open frame, so you can totally get in there and rough it up a little bit. So that's why we use breakaway support. So definitely a really great, I feel free to be able to like design this, because if I design this with no supports, it'd have to be a two-part thing where you glue them together. You'd have to have two flat surfaces and glue those together.
Yeah. And then you run into your tolerances changing because of the overhangs.
Yes, that is exactly true.
Busting out my part just to show that next week's project also heavily uses
look at that
breakaway supports.
Huge fan of breakaway.
Of the way the standoffs are for this, I just can't print this, you know. Whichever way I go, there's going to be a standoff.
Get a little bit closer. There you go.
I think it's in the way.
Yeah, so you can see that support interface is what's really keeping the PLA in place. So it gives you that nice flat dimension that you need.
What I'm pointing to here is the fine detail that you're able to get out of just a 0.4mm nozzle.
Yeah.
And it adds supports on the inside of your standoffs.
These are standoffs, yeah. So that's like an M3 hole, and that's pretty much the smallest thing you can make. That is so cool. Yeah. So you might be asking, so what are the slice settings for your breakaway supports?
I have all that
set up. I'm glad you asked.
Oh, actually, it's very easy. Whatever the default stuff that Ultimaker put on there is what I ended up using.
Me too. I also have it broken out. I took a screenshot of it just to show the infill density. I did change that, but other than that, you know, there wasn't much else to mess with.
Oh my God, how tiny the support is for the inside of the standoff.
It's ridiculously small.
Whoa, what was that?
It was definitely glass.
Oh.
Yeah. What was it though? Was it the light bulb? I don't know. It's literally behind the computer where all the cables and stuff are. So let's go look at the Learn Guide and talk about the actual breakaway support.
This isn't what we meant, honey. Not breakaway. Break something.
Breakaway. So,
sorry for the mess my wife has now made.
Oh, come on, it's not her fault. It's their show. Focus.
Imagination to form says, don't worry, it's just gravity working.
Yeah. Okay, that's a good way to look at it. So this breakaway support stuff, it has a built-in profile that's a part of Cura. We're using Cura 3.4X.
And again, the default stuff works excellent. There's nothing you need to change.
There is. I would drop the infill. I would drop it to 20. I didn't need 50. For whatever reason, it's really high.
I like the triangular infill that it's using as a as the default.
Yeah. Also, you'll notice that the interface is like concentric. So I guess that works out.
Yeah, you can either leave that on or turn it off, but it does, as you've seen, create a very beautiful overhang on the bottom.
Yeah. I'd like to see other printers, dual head extruders take a stab at breakaway and see how that works. Maybe to see the Sigma at work or one of the Taz more extruders. That'd be cool. So that's the motion link. That's just you need to print 2 of those, and then the drive hub. Those are the only 3 parts that need support material. Other than that, everything else prints without supports, and they're oriented to print as is. So they're already flat on the bed for you. So it's nice. We do have the Ultimaker 3s in stock. We are distributors of them. One of our favorite printers. We use it a lot of great material combinations that you can do, and the print cores are just solid, man. They just work really well. So shout out to the Ultimaker team. We also have a link here to 3D hubs and MakeXYZ. So if you want to have somebody 3D print it for you and ship you the parts, check out some really cool 3D hubs like Kirby. He's got a nice hub. And you can check out Make XYZ as an alternative, or you can just hit the order buy button on Thingiverse. I think there's a buy button somewhere there. And you can order it. It works with 3D hubs. Cool.
Yeah.
All right, let's work into the software. So for the software, this is really cool, and this is actually a two-parter thing. This can run in both MakeCode for Microsoft and CircuitPython from Adafruit. So we got both options for you. For me, though, I broke out and explained how to set up MakeCode because I understand it and I like it. So for MakeCode, we have the Crickit extension that allows you to control the motors and all the peripherals and I/O from the Crickit. So you just install that. So what's cool about this one is that it's a really, really simple program. All it's doing is it's telling the motor, it's assigning the values from the potentiometer to the speed of the motor. So that's pretty cool. So to do that with MakeCode, in your forever loop, all you need to do is drag one of the run motor blocks, assign it to whatever channel. In this case, I'm using channel 1. And then what you want to do is you want to grab one of the map blocks from the math category, the purple blocks, and then there's one called map. So mapping is what takes two sets of values, two sets of two values, and maps them. So in this case, we want to take the values from the potentiometer. Potentiometer is analog. The top value that it can produce is 1023. So that's our high. Our lowest is 0. Then the next set of values is what you're mapping to. So in this case, we're mapping the motor speed. Motor can only go from 0 to 100. So we're mapping the second part, low, 0, and the high is 100%. So with that, you're basically mapping the values from the potentiometer to the motor. Don't forget, you need to write what you're actually pulling from. You're actually pulling from the analog read signal, which is a part of the signal I/O section on the Crickit, and that is in the Crickit extension MakeCode block. So that's under the signal I/O code block. So you can assign whatever channel. In this case, we're using channel 1, and that's what the potentiometer is plugged into, is the channel 1 signal I/O. So that's how we're doing it. Pretty well. We also have a note here on if you want to kind of change the minimum value from 0 to 25, just in case you want the motor to kind of start up actually doing something instead of at 0. Another thing we did was, well, this is Lamar. So shout out to Lamar. She put together the code for the CircuitPython edition of this project. So we got a nice link for how to set up the special build firmware for the Crickit in Circuit Playground Express. Just a simple drag and drop of the UF2 file. So we have that. And then we also have a nice link to the Mu editor. So if you are new to Python and you're looking for something better than text edit, you can use the Mu editor from Nick Tull and team. So it's a nice IDE for kind of beginner Python coders. So here's the code for Python. It's just embedded in here. We're setting up the seesaw. We're setting up our potentiometer to be on signal 1, and then we're setting up the motor to be on channel 1 as well. In our loop, we have a little bit of a log helper here where we're getting some readouts of the pot. We can see that it's actually connected. And then we are assigning the motor to map the potentiometer. So that's how it's done. Very simple line of codes, and once you see it, it just makes sense. That's pretty cool. So those are all the, that's the whole software page. It's cool that we have, we're trying to do this more where we have both CircuitPython and MakeCode. So that works out really well, I think. Yay. So after the software page, once you have it up and running and your Cricket's, cricketing, then it comes down to the assembly. So we break down all the steps for wiring up all the components, really trying to stay modular so that when we're panel mounting things, we don't have to like panel mount it and then solder the wire to the thing that's been panel mounted within, while it's in the case. So this is cool because you can just wire everything up and then stick it in the case later. I like that. So the way to do that, you really need to use plug and play connectors. So in this case, we're using a lot of jumper wires. Wire lengths and all that is all listed here as well, so that's really nice and handy because it is pretty tight in the box, so you want to make sure your wires are nice and lengthy or shortened. So yeah, using male headers and kind of hacking them into this. Pretty cool. So I'm actually using a right-angled DC plug here just to kind of save space. So you kind of do need one of these. We don't stock these, but you can get like a pack 20 of them from Amazon for like $2 or whatever. So that's cool. I soldered some of these male jumper wires to the wires so that I can plug them directly into female jumper connectors.
Which is going to start being the theme.
It's the theme,
with
yeah,
all
man.
of the jumper wire converter
So many jumper
type
wires.
adapter cables that we have.
Yeah, more JSTs and stuff too. Wiring up the wiring up the potentiometer. Same thing. Female to male jumper wires. We have a nice pack of these extension wires. They're like nice and short, and there's a bunch of different colors. You can get a pack of these for like $4, and there's all sorts of different colors. But they're really nice premium wires. I used 4 of them here, 3 of them for the ground, the voltage and signal, and then the on-off switch gets 1 extra one here, so I have a 4th one there. Yep, so I walked through wiring up the potentiometer. I thought it was interesting that female jumper wires don't really plug into the little terminal leads on the potentiometer. You actually have to thicken them up a little bit, so I tin them, and they seem to hold on pretty good. I can still pull them out. They're not soldered. It's just tinned, so I can pull out those things if I need to. Don't need to, but it's nice that you can. And then wiring up this single extension jumper wire to the 2 terminals that do the on-off switch. It kind of looks like a little octopus. It's all like, hey, what's up? Wiring up the DC jack. Again, more jumper wires. This time the female type, because we are wiring in line the on-off switch. When it comes to assembly, it's just putting all these things together. So and it's sort of following the order of the assembly. You want to do it in this order so that you're not having to pull it, take it apart, just plug in a cable. So that's why I have it ordered in this way. So you kind of secure the board with the machine screws, and then you start installing everything into the frame. The way I designed the enclosure is that it's a 3-piece kind of dealie. So you have a top and a bottom cover, and you have this like frame. So you're just printing a frame instead of it being attached directly to the bottom or the top cover. I like doing that because then you can get access from the top or the bottom, so it's kind of a neat thing. Snap fits, of course, so it locks and shuts when you close it. So everything gets mounted. Panel mounted is the potentiometer and the DC jack. Those come with their own hardware screws, so those just you reuse those. Let's see what else. The USB cable comes with 2 screws. They're like these long M3 screws. You just drive them in through the case and into the little tabs, the little mounting tabs that it comes with. So that works. Just running through it. It's pretty thorough. There's a lot of little nuances and things of routing wires, but for the most part, it's all listed here. Yeah, and then after that, plugging everything is really nice and easy. So plugging in the jumpers from the pot and then connecting the micro USB, it really is plug and play there. Definitely want to tidy up the wires. Kind of walk through a little bit of doing that, but I was happy I didn't have to kind of cut and shorten any of the wires. Mainly like the USB cable, because that's typically what happens. Like the panel mounted cable is too long, you have to cut it in half. This time I didn't have to, I just coiled it around and kind of tucked it in between the edge of the case. As far as the final assembly goes, it's more about kind of creating the mechanism for the rotating platform. It's mounted to the top of the case, and it's like this little triangle bit. I call it the cover plate. That has 2 little nubs. That's where the ball bearings snap into, and then the third little hole on the corner is actually for the motor hub. So the shaft of the motor pops out of that. So the motor itself is attached to the cover with these long machine screws. And then the shaft of the motor kind of protrudes from that hole in the corner there of the triangle. So the thing there is once you have that installed and snap the case, you can fit the drive hub over the shaft of the motor. So that just plugs in. No glue, it's just press fits. Same thing with the ball bearings. To create the platform, it's kind of these 3 pieces that kind of get sandwiched together. You have the tray, you have the actual platform, and then you have the holder. The holder is what actually holds. You don't want the container to fly off the tray, so that's why I designed a custom fitted jar holder, container holder.
John K was actually asking, how do you actually hold the jar on?
Yeah, exactly. That's how you do it.
You would have to get this part right here.
Yeah.
And then over the overhead.
Yeah.
Just custom part of that.
Yeah, I was looking.
Onto that.
So yeah, I do list the diameter of the.
Screws in?
Yeah, of this guy. So this is 73 diameter. Let's see, 73 millimeters, 2 inches. That is 2.8 inches in diameter. So hopefully that's like a standard. I don't know. Where did you guys buy this? It was like from,
This was at Michael's. It was just
Michael's?
I think like a container box.
Yeah.
Somewhere in the kids section.
Yeah. And if anybody wants, I could probably design a custom one. Just give me the dimension. I'll make it. It should be pretty easy. But it has it just has a nice kind of hold to it. It's not glued in there. It comes off easily. It snaps in there. I put these little notches in there so that I would be able to get my fingers down there if it was too tight of a fit. But no, it worked out pretty well. So dialing in the speed just when it starts moving is probably right. Because if you go too fast, the thing starts wobbling because there's too much weight on it. And this is how it sounds. It's not too loud. It's just kind of like ambient noise in the background. That's actually full throttle. Okay. But there's no water in it yet. I didn't put any water in it. So that's it. Yeah, this is the 2.1 barrel jack, the 5 volt, 2 amp power supply. So putting together these ball bearings are definitely really nice. Shout out to Greg Zumwalt for bringing that to our attention. We didn't know about these ball bearings, but they're really nice. These. Super thin. They have a big inner diameter and a small outer diameter.
Which is really good for parts, since you can actually print a nice big old fat standoff that won't break off.
Yeah, it'll hold support, yeah. That's really nice. I like those. You can get a pack of 10 of them on Amazon, so check those out. Yeah, I have them listed there. So they just pop into those into little caps of the tray, of the bearing tray, and then you can snap on the motion links onto the bearings there. So you need a total of 5 bearings because you have to double up on those motion links. After that, you can install the platform by just press fitting the bearings onto the motion links, and they just snap in there. You gotta make sure that they're all oriented in the same way, otherwise they won't match. So once they're all snapped in, one link will control all of them, and they'll all just kind of rotate. So that's how the mechanism works. That's the final assembly. So the last page is the last page I worked on. Talks about the usage, right? So how do we do the test? What are some notes on how to use this thing? So that's what we did here. We got nice photos of the parts. Yeah. When it comes to printing the actual part and what the part is that we printed in this project, it's actually called the Hilbert Cube. It's on Thingiverse. It's right here. This was actually by Tony Boozer on Thingiverse. And he put this together with a processing Python script. So he wrote this with code. But there's a wiki page on the Hilbert Cube. It's a math equation. And you can definitely support and donate to Wikipedia. Yeah, so David Hilbert came up with this. And there's a lot of info on that. So if you want to know more about the Hilbert Cube, you can check that out. But for this one, it looks like this was printed like on a Thingomatic way back in like 2011. So this was
one to me.
Yeah, so like dual extrusion tests back in 2012. It's really cool. So the models for you to download, there's different types of models. There's a really smooth one and more of a kind of a blocky one. What's funny about this is that Tony actually has custom support material designed to fit with this, because back in the day, slicers weren't smart enough to generate their own support material, so you had to create your own support material. But nowadays, you can your Cura slicers and Simplify 3Ds, they create really good support material for you, so you don't have to create your own. So that's the Hilbert Cube. I'll post a make on it a little bit later. And if you're looking for more, oh wait, not done yet. So the Hilbert, slicing it, here's how we sliced it. I took a screenshot of all of the slice settings. There are quite a few, but these are the main ones. So I kind of laid them out because if you look
these were actually grabbed from the PVA Learn Guide.
Yes. So yeah. So we got this. This is specifically the one. And then if you are looking at our D20 guide, this one talks more about calibrating the nozzles and kind of walking through the process of setting up the Ultimaker 3 with the PVA nozzle, the BB nozzle. Pretty straightforward, but all the details.
Just a couple of settings that they actually might roll into like default settings, hopefully in the future. So this might be outdated.
Yeah, maybe.
Hopefully, this is one of the ones where I hope it becomes outdated and they just roll those changes into there.
Yeah, all we're doing is increasing the standby temperature, Increasing the thickness of the prime tower. You do want to use a prime tower, or at least in our test. Prime towers
Doing
really
a little
work.
bit more of priming too after you're switching between the nozzles.
Yeah, the default's like 1 millimeter. This is 2 millimeter thick. Also, the tower size is increased to 20 millimeters.
Yeah.
All those little details go and kind of showcase. Earlier, we were showing our PVA prints, and one of them looked a little under extruded. And I think that's the one where I didn't use your settings, just kind of default settings. So you kind of see that. Wrong one. Here we go. So here's the PVA. It's easy. I mean, it's gonna look like that. It's not gonna look solid and beautiful because it's the way PVA is. You're printing with glue. So don't expect like super clean geometry from your PVA. I printed this, I want to say like 2 weeks ago, and it's just been sitting there. So I guess there's no, it doesn't like dry out or anything once it's been printed. But this is the one that's printed with not bigger, thicker, stronger prime tower, and this one is with the bigger, thicker prime tower. You can tell because it looks like it's filled in more. Plus it has more infill as well. But both fine prints. They take about 3 to 4 hours to print because it's got to cool down and print each layer and switch the nozzle. So those are the parts. This is what it looks like once it's been cleaned up. Really, really awesome geometry. You can see there's a little bit of holes here and there, and that's just from the contamination. Not everywhere, but hey, it works pretty well. This is using Filamentum's Vertigo Galaxy PLA. You got a little bit of flex of this here because of the way the pipes are, so you get a little bit of flex of that. Look, there's a little bit left there, actually. It's just been an earlier one. I should have let it soak a little bit longer. There's another one. Do you have a smooth one? Yeah, here's the smooth one. It's like completely filleted, so there's fillets everywhere. It's a little bit less flexible. I don't know. So those are the prints.
Cool.
Yeah, pretty cool. All right, so if you guys want to make your own, you can use the Crickit. It's a good option. There are some other DIY overder shakers out there. Those are really nice ones. But this is one that uses the Crickit. And a lot simpler, I think, in terms of sort of the part design. Yeah, the assembly. Nice and thorough, too.
Yeah,
some of them don't have thorough guides.
editable designs.
Yeah, totally. Hope you guys like it, and I'd like to see, I don't know, people use it for other things I never thought would, like making cocoa. That was a good one. So you want to pick up the Crickit, you're going to have to go somewhere else, because we don't have it in stock. But our friends at DigiKey has a good shipment in, so you can get those or ship immediately. We do have the Circuit Playground Express. That one's in stock, so if you are out of your Circuit Playground Expresses and you need more, they're in stock, so you can check them out. Coupon code Shake It Off. Sweet.
All right, let's go ahead and jump into this week's, what are we, prototyping?
Yeah. I'm looking for this one. Go. All right,
So last week I showed off my current work on the saw blade.
Which camera you want?
One of these.
Face? You want the face one?
Not going to focus too much time on all the cool little greeblies that I got on there or the lights that we have working. Let me turn that on real quick. That's all cool. It's all working. Got all the LEDs in there. It's all nicely diffused. Added all of the buttons for controlling all of the different functions, like turning on the motor, changing the animations. Got the UV reactant filament on there. So that lights up all nice with the UV LEDs on the inside. Today we're going to take a close look at the handle that I got going on here. So all NinjaFlex prints in different pieces. So we have a 7/8 inch dowel on the inside.
Yeah, it's a
nice
wood
and
dowel.
Grippy. So unlike the previous sword, you can have both hands on there. Have a nice amount of room on there so when you're swinging this guy around.
Check it out.
Cameras.
Bam. How do you like that?
You're switching cameras.
No, I'm switching text, man.
Okay.
It takes like 5 minutes to switch text.
And the cool thing about this one here, if I switch on the diffused
it's a great method of getting little bits of light without a lot of intense wiring. So this is our little breakout board that has the 2012 coin cell battery. Little LED. Yeah.
So if you just add this on here like that.
Really cool.
Yeah.
So NinjaFlex is like a sleeve. It's not the whole. It's just like a sleeve that
it
slips
just adds the
into
textures on there, like the stitching pattern that's on there, so I will paint this in like that yellow color that they have on there.
I like the brown. It works well.
Yeah,
this is all gold Ninja Flex.
Yeah. So in about 1 more week, I will have all this finished. I'm about to shoot all the assembly for this. And yeah, turn out really great.
Yeah.
We'll show it off with the
About
UV
3
lights.
feet tall.
Yeah, it looks crazy amazing with all the UV reactant filament that we replaced on there.
Yeah.
So pretty cool.
Like 3 different types of NeoPixel strips in there. We got the UV ones.
I really like this
side-lit
Galaxy gold flakes for the PVA.
Yeah. Really
really
get
cool.
that.
And it's nice and shiny. Yeah. Take a look at all the different techniques that we use to build this. Cool stuff going on in there. Tons of like little design features that make this work out really good.
Yeah,
so take a look at it in about a week or 2.
Sweet.
Pretty cool.
Excellent. All right, so we went to layer by layer. Yay, finally did another layer by layer. So was it Friday? I think it was Friday. Friday, I put together a little layer by layer on how I export stuff out of Fusion 360 because it's a little bit tricky. So I walked through how to do that. If you're using linked components, you have to kind of break your links, and sometimes projected geometry might break. So I walked through fixing those errors, and more so promoting the GitHub page that we have that has all our CAD drawings for the Adafruit boards and various components. So check that out if you haven't seen it. If you like layer by layers and you like Fusion 360, it's a nice little tip. And I'll get into the motion of doing more of them. So from that, we have the GitHub page. No new products, no new parts were modeled this week because we're doing all the guides and videos. But we had a nice assortment of them last week. The DC barrel jack, basically all the components in this week's project, all the models, you know, cables, plugs, and stuff. That's all going to be on GitHub very shortly. I need to get that out there after the show. So that is the layer by layer and the parts on GitHub. Cool, let's walk into Shop Talk. So for Shop Talk, I wanted to sort of highlight this new product that we have in the shop. You probably have seen it. It is the Hallowing. We're out of stock because everybody bought one. We're making more of them and putting new firmware on it as well. So this is the Feather Hallowing. It's more of a feather and not a Halloween because it actually has the same D21 chip on it. It has built-in accelerometer, built-in NeoPixels, built-in capacitive touch, built-in amplifier, speaker, connectors. Man, this thing's got a lot going for it. This is really becoming like the prop wing or something. Like it's the prop wing. So I don't want to just show it. I had to make a case for it, right? So I made a case for it. This is a case that came up for the Hallowing. It follows the contour of the board. It kind of closes this off here, so you can still access your cap touch stuff. Not much going on at the bottom, but the top here we have access to the USB port, and then I have these little kind of these little horns that have little loops, so you can put these. I forget what they're called. They're like clasps, maybe not. As I get manual focus, yeah. So this is printed in gray. Vertigo Gray from Filamentum. I'll have the on and off switch accessible kind of here, so you just kind of use your fingernail in there. So inside here I have a little battery. I have the 110 milliamp battery. So this case keeps the Cabutron, the glass lens. It has a little bit of a flange, so it's able to hold in there pretty nice. This is interesting. It's a snap fit case, so I have one snap fit nub here with this really extreme kind of chamfered edges, and then this edge over here as well. So a little bit of a gap there because it's really tight in there. But as you can see, there's the LED from the backlit display. You have a little bit of access there for the NeoPixel, but other than that, you don't have much access to anything else. So that's what it looks like. So. I will put it on GitHub shortly, I guess, after the show, because right now I don't. But yeah, the way it works is you snap it like this. This snaps off like that. And it's a really tight fit because it follows the contour of the board so precisely that there's literally 0.2 millimeter of clearance between the edge of the board and this thing. I'm having trouble here taking it out because the way the snap fits, they're really right up against the PCB. So I have to kind of flex it outwards to get it in there. But let's get a look at that thing snapping. So let's see kind of how it works. Like that.
Wow.
So that's pretty nice. Nice chamfered edges everywhere. And it's easy to get your finger in there, pop it out. But again, the actual PCB is what's in my way. Why is it so hard to do it now that I'm live? Of course, it's harder to do it. Struggle. Why?
It's too small.
I don't think it wants to be taken apart. It's like, whoa, what are you doing? Well, once you put it together, you can never take it apart. How's that? No, maybe I'll play with it a little bit more.
Yeah, somebody was asking that this would make a great doorbell.
And it was a doorbell.
To the Purple People Eater.
Yeah, this is a Purple People Eater project we did a couple Halloweens ago.
Yeah.
And it was the first kind of time that Filip made the code, right? It's like the first year he made the iCode.
Oh, yeah.
And I was like, I got to make this into something. So I made it into a doorbell where you push the I and it pushes a button. So yeah, Pedro has the guide there. I don't have the guide.
I just noticed the
YouTube video was never added?
The embed, yeah, it was never added.
Is that why nobody ever saw it? Maybe. Sometimes we forget. So yeah, if you type in purple, there's the guide. You literally touch his eye. Look at that GIF. You touch his eye to
Hold
turn
on.
the
Reload.
thing. Hey, there's a video. Oh, that's great. I also put a little horn on him.
John Park says it's a coffin for the Halloween.
It's a coffin for Halloween. It is, because you can't get out buried alive. So anyway, the doorbell. Yeah.
With wings.
So hopefully it gets in stock soon. We got to make more of them. Where is it?
Yeah,
There it
somebody's
is.
saying, Thomas is saying that the 2-week lead at DigiKey for the Crickets. Oh, sorry, for the Hallowings.
Right. Another thing about this is I had to take off the foam tape. So there's actually a thick piece of foam tape that's behind the screen. So the way I got rid of that is I dipped the spudger in alcohol, the tip of it. That way I can kind of loosen up the adhesive because it's very delicate, totally easy to break and damage the display. I don't recommend doing it unless you have another one or you've done it before. But I needed to get it as flush as I could, the display as flush as I could to the PCB, so that's why I had to take off the thing. So if you have that and you try to put it in this case, it might break. What a deadly case! Like this case will kill you. Like, what's going on? Anyway,
It's because you're on air. Nothing works on air.
sure. If you guys want the 3D model of it, it's up on GitHub too. I think maybe we brought it into Fusion. Anyway. Shop talk. We're going to jump into Community Makes.
Is it time for this mask yet?
It is. I'm going to show the time lapse here. So, this week's Community Makes, we 3D printed this mask. It's Immortan Joe from the Mad Max movie. It's a mask printed on Ultimaker 2 Plus with
I wanted to see
TPU.
if the Cheetah TPU from NinjaFlex would print with the 0.6mm nozzle on this.
This is cool.
And I wanted to see like how well the overhangs were, and it came out pretty good. So I decided to go ahead and try airbrushing after a year of not touching that pretty sweet machine.
Oh, that's funny.
I was able to set up and get some pretty fine detail out of all of the
That's some good shading.
crevices and like all the little detail that did come out on
The layer lines almost adds like a bit of kind of weathering to it a little bit.
I think I printed it at what did it say, 0.3mm layer height?
Immortan Joe mask. Yeah, so if we go over to the Thingiverse page, this is designed by Alex.
Yeah, check out
and
his
he has a phenomenal.
post-processing
Yeah,
on this.
he spent
Wow.
a couple days painting this. So.
Yeah, if you read the description, he says that it is a couple layers of acrylic that he used to get super cool post-process.
Super cool
look.
work on the strap there.
Yeah, some nice leather on there.
Yeah, super sweet photos.
Complete look
He's
at-
ready for Halloween.
look
Are
at
you guys
that.
ready for Halloween? Yeah, he printed in black ABS, I think.
Yeah, I think the 2 tips on this, print it at the highest layer size that you can. So you print it at 100 microns. I just printed this like at 0.2 or 0.3 just to get it out the door.
Yep.
Super fast. This was all like one of those. I was trying to do like what's his name? Like the 1-day builds that Adam Savage does. So I was like, oh, let me just give you 1 day to just put this together, see what I can do.
Yeah,
and
that's pretty cool.
That's what we got. So take a look at the details here. Oh, the second tip. One of the remakes shows like a bunch of support material.
Right.
You can actually just lay this flat. It is going to take a bit of finessing to get the rotations to work pretty good, but you can lay this flat on the bed. You'll actually have to submerge it a little bit underneath the bed.
Yeah, that's a good tip. Yeah.
So you can get this nice and flat, and then you won't need any support material for that.
Is it just perimeter, or is there some infill?
There is some infill somewhere around here, but it's like 10 or 15%. Triangular infill, and then we're just using these I forget the name of these just with the C conduits, yeah, for like wires, like for computer like cables and stuff like that, and those fit nicely into the also NinjaFlex the tube things. So these are the black cheetah that we have in stock.
Somehow like that. Something.
Have it like a third eye.
Right there.
And that's the cool thing about the Cheetah NinjaFlex stuff.
Yeah,
you can just flex. You can push that in like that. You can actually cut these. So I just use a regular hole puncher to create these.
This is great.
Didn't want to add that in the geometry because there would be some retraction issues, especially around like these thin outer edges.
Right. That's a clean hole, man. You couldn't have printed a hole that clean.
Yeah, just a regular hole puncher.
So that's great. You can cut it with scissors. You can sew to it. If you want
that's
to
actually
sew
what I should have done up here, cutting it just to have like a little bit of breathing on there. And then we're just using one of those lace like necklace things.
Yeah, necklace strap
holder.
And it's TPU. This stuff's tough. You can run over the car. You can try to tear it. But you can cut it though. It's great.
And those just push in
but
like
the thing is, you can totally spray paint NinjaFlex. Right?
Yeah, that was another thing too, that you are able to airbrush right on top of NinjaFlex.
Yeah.
And it does a good job. It doesn't just wipe away after you've let it dry.
You want to put it on now?
Ah, you can put it on.
Oh. I'm just better putting it on. This is just for you, Jim. Now he's going to wear it throughout the whole show.
What is the thing they say?
Witness me.
Witness me.
Well, he doesn't say it. What are they called? The Lost Boys? No. The Wild Boys?
Yeah, so super cool. Yeah, just add like some vent there for your nose.
What do they say? Like, may the gasoline burn brightly or something, I forget. We need to watch the movie again. It's great. One of my favorite ones.
Yeah, so super easy Halloween. Takes about 6 hours to print.
Does it?
With the 0.6 mil nozzle.
Yeah.
And yeah.
I don't know if you said, but this is Cheetah NinjaFlex.
Yeah, we do have this in stock in the store.
This is printed on a boated machine. Like,
printed on a boated, on an Ultimaker.
How did you...
I use the default settings.
I can't wait for the fail at the end. It's going to be the best. So you can see this printing beautifully now. It can.
I think after the third try.
This is third try? Okay. Because, you had the retraction turned on, and it still worked really well. Again, it's Cheetah. Cheetah's built differently than the Superflex. Anyway, we already showed the video, so check out the thing on Thingiverse. Shout out to Alex for sharing that on Thingiverse. And here's the make that Pedro was talking about with the supports. You don't need supports if you orient it correctly. Oh, look, there's another one. Somebody just posted this.
That looks amazing.
Whoa, look at the detail on the teeth. Whoa. Oh, that is super sick.
There's a couple of
Hawk
3D pros saying, wow, I need one of those.
Wow.
Oh yeah, that would be a cool mask to use while sanding. It says Hawk 3D.
Oh, that'd be cool. Kind of
a good
upgrade your existing masks and equipment. You don't need to print it this way. But hey, if you got supports, why not do it? You're gonna post-process it anyway.
I mean, it'll take longer to add all the supports in there that you don't need.
That's cool. Sweet. All right. Well, there you go. Got some other things for you real quick. We're gonna run through them. Got 10 minutes left or so. Somebody remixed, this user here, Thingiverse user SB43201, remixed our last week's project, the Internet of Things Gmail box. He remixed the design to fit a Wemos D1 Mini and an SG90 servo. So those are the sort of less expensive products. Not as fully featured, but still pretty good. And he designed the case around it. Oh, he put a video up too? Sweet, I didn't see that. There it is running.
Sweet.
He also modified the horn. Yeah, the flag, so that it like press fits into the horn. A little bit better design, I think, so nice job on that. You can see here it has like the outline. You did that once, didn't you? I didn't do it for this one.
What's that?
I should have did that. I just glued it. So instead of gluing it, he put an imprint there, like a recessed.
We do have it in the parts
Yeah,
folder.
I didn't do that. And he put a bigger hole here for the SG90, because I used the sub-micro servo.
Did he remix your Fusion file? Or?
Yeah. He
Sweet.
said, thank you for sharing the Fusion file,
Awesome.
basically. Yeah, and Adafruit IO, still using it. So yay! Awesome, and he's got a Fritzy diagram. All right, well that's that one. This last one here is another awesome make of Pedro's Guardian Sword with NeoPixel LEDs from Zelda Breath of the Wild. It's a video game. So this is Thingiverse user Elsie, I want to say Elsie. She is cosplaying as a Guero.
Super
awesome.
cool outfit to go along with the cool prop.
Super gorgeous, yeah. Matches really well, like coloring. Man, that blade just lights up the picture.
Yeah.
Very cool. Nice elf ears.
Good job. Like it.
Super nice. We saw it on, I think Instagram first. So
yeah,
if you just now posted it, which is great. Yeah, so there's the sort of the build. Really nice. This makes it number, what number? Number 18.
Wow.
Make.
Cool.
5 remixes. So excellent. Hopefully people get a kick out of the new sword, this year's Breath of the Wild sword. There's some other great projects on the show and tell, so you can check those out. There's a show and tell page that you can check out. And if I can find it, where is it? Project Help, show. I'll top it to here, there we go. Show and tell, there it is. So there's some awesome projects from the community.
Wow, look at this.
Cool, looking at Andon's display here.
Yeah.
He's doing some UI stuff. Got this nice Cherry MX custom PCB from looks like from Construct, and just overall awesome stuff. Shout out to Brent, who just released a really awesome home automation guide using Adafruit IO. This thing is stellar. So if you go to the Adafruit Learning System, check out all the awesome guides actually. So really cool one here. And Dana Wall came out with an amazing one. This is a paper airplane launcher, super dope. You want to do some light painting, John Park sketch cover,
so cool.
using the Hallowing to create some really phenomenal works of art. So check that out. You can watch John's stream as well from last week. Shows you how he put it together and walks through kind of the process of kind of setting up these photos too. So very, very awesome work.
I believe the easiest way to get a light painting stick.
Yeah, super cool. You get some nice stuff. He did some nice stuff with the playground, like using the playground to create these kind of John right there. Some rainbows.
That's so cool.
Oh, look at that skull. That's so dope. Drinking water with it. DigiKey. John Park. You gotta do your own logo.
Yeah.
That's dope. So very, very cool pumpkins.
That's so cool.
Yeah.
Go,
oh man, you gotta make them for Halloween, guys. Come on, this is all freaking fun. So cool. All right, and then this is really cool too. Look at that. This is all done through the web. There's no Bluefruit going on here. It's all done through Wi-Fi, or LTE rather, because it's in the cloud. So very cool way to kind of. He has 3 different strips, I think, 3 different type of ways to light. So and then a temperature sensor as well. So Brent walks you through all that stuff, setting it up. It's the Raspberry Pi based project. Very, very cool. All that and more on the Adafruit Learning Systems. Check it out. If you guys have some awesome projects you want to share with us, please do so. You can hit us up on any of the social channels. We'd love to share them on the blog and beyond. That's going to be it for this week's show. We'll be here next week, but for now, we have Shake It Off as the coupon code. Don't forget. Later tonight, we have Show and Tell. So if you want to stop by, let us know what you're working on. Maybe you got some retro gear that you found that you want to share. Wednesday, that's today, 7:30 p.m. Eastern Time.
Then immediately following that at 8 o'clock, we got a whole hour with Lamar and Phil. Got all the cool stuff going on at Adafruit.
New products.
Cool new products, and of course, top secret stuff. And all the news. It's all fit.
Different or something. Well, thank you guys so much for joining us. We'll be here next week. Good luck with all of your endeavors. And don't forget to make a great day. We're going to leave you with this week's, what is it called?
Fail.
Fail. This week's fail. Bye, everybody.
Guys.
Thanks for tuning in. It's squished. double broken.
This was the where it got tangled up in the spool.
Yeah, so this was not actually the printer's fault. It was not. It was the spool's fault. And who spooled it? Fender drives. And whose Fender drives? They make NutriFlux. Oh, my mic is still on. Yeah, it worked out though after the third time. Bye, everybody. See you tonight. How long did I record this for? Jeez. All right, I gotta go. Bye.